Nearest neighbor analysis. GIS is very useful in analyzing spatial relationship between features. One such analysis is finding out which features are closest to a given feature. QGIS has a tool called Distance Matrix, which helps with such analysis. In this tutorial, we will use two data sets and find out which points from one layer are closest to which point from the second layer. This kind of analysis is very useful for environmental conditions analysis. For example, we have habitat for different species on the one hand, and on the other hand, we have populated places. If people want to visit these habitats, they can find the nearest place of destination for their activity. In this example, we will analyze significant earthquakes, and we will find out the nearest populated place for each location where the earthquake happened. In this exercise, we will perform table joining, and we will use Query Builder to show a subset of features from a layer, and we will use MMQGIS plugin to create hub lines to visualize the nearest neighbors. Well, following the link, we can find the North American National Ocean Atmosphere Association of the United States. We can find significant earthquake database. Well, this file is absent. However, I have this file on my disk, and I will share this file with you. Another layer is populated places. So, data, earthquakes. Yes. You can find the TXT file with information about prominent biggest earthquakes. Another data set is populated places, and now I will run QGIS application, and we will try to make this kind of analysis. So we have two data sets. First data set is significant earthquakes, Another is populated places. The procedure of working with this data is to add a new layer to QGIS environment. We can add delimited text layer and browse to download SIGNIF.txt file. Since this is a tab delimited file, we choose tabulation as a file format, and X and Y field would be auto-populated, and then click OK. You may see some errors messages as QGIS tries to import the file. These are valid errors, and some rows from the file will not be imported. You can ignore the errors for the purpose of this tutorial. This errors is connected with the some earthworks has no latitude and longitude data, and so QGIS cannot import this data from this TXT file. Well, let's try the we are creating new project and try to go to layer, add TXT data, tabular data from C earthworks significant earthworks, and then we can use Y coordinates not Unicode, maybe UTF-8. Yes, UTF-8, and we can use X coordinate. X coordinate is longitude, and Y coordinate is latitude. Yes, let's check. X is longitude, Y is latitude. You probably know that latitude and longitude are coordinates that show the position of the point on the Earth's surface. Well, also it is important to check top button for the separation between columns in this TXT file. Tabulation, X longitude, Y latitude, well, and we can add this data. Okay, you can see the shape of these earthworks onto world map. We also, it is possible to add background as OpenStreetMap background, and we can find all these important or significant earthquakes all over the world. Well, next as the earthquake dataset has latitude and longitude coordinates, it will be imported with the default coordinate system, EPSG 4326. Let's check. 4326. It is coordinate systems of our project, which mean the way of drawing points on a flat map from the Earth's surface. Well, then we need to add populated places to a map. We go to the layer, add vector layer, and choose the path to this populated places and use the file with SHP or shapefile. Open, add. You can find another layer of QGIS show this layer with points, and we can change the appearance of these points, for example, blue or red, yellow, every color. Let it be kind of pink color for population places. You can see Mykolaiv, Kherson, Kryvyi Rih, and other Ukrainian cities. Well, then we try to zoom around and explore both data sets. Each point represents the location of significant earthquake, and each blue point represents the location of populated place. We need a way to find out the nearest point from the populated place layer for each of the points in the earthquake layer. We should go to vector analysis tools and distance matrix. Let's try. Vector analysis tools. Distance matrix. Well, we can see the dialog with options, and we should accurately select the proper. Here the earthquake layer SIGNIF as the input point layer and populated places as a target layer. Well, SIGNIF and populated places целевые, target layer. And you can see after we use correct file, the matrix has been created. It is a temporal layer. We can save this layer as permanent. For example, gear package. For example, gear package. Set data. Set data earthquakes. Matrix. In this matrix of distances, we can find the attribute information, and in this matrix, we can see the ID of earthquake and the nearest target city. We have more than 5,000 lines, and then we should make a connection and display this data on a map. Here you can see the attribute table of this matrix. This is very close to the result we were looking for. However, we can also integrate this result in our original earthquake layer using a table join. We can right-click on the earthquake layer and see properties. We can join this matrix to non-null properties, join, plus and can join all this data. OK. Run. OK. And in this attribute data, we can find the result of join. The identification number of earthquake and the nearest city, and then the distance between earthquake epicenter and city. Next, we should see this part of the table. And now we will explore a way to visualize this result. First, we need to make the table join permanent by saving it to a new layer. We can right-click the SIGNIF layer and select Save As. we can use the name earthquake with places. Uh, Save as shapefile in the same layer. See data earthquakes. Ok. Then new new file in the browser earthquake with places. This file is situated in the same places as the earthquake with non-null geometry. And then we need to once the new layer is loaded, you can turn off the visibility of the Fignifilet. And as our dataset is quite large, we can run our visualization analysis on subset of the data. In General tab, we can scroll to the Feature Subset section and click Query Builder. For this tutorial, we will visualize the earthquakes and their nearest populated place for Mexico, country Mexico, and we will see that only the points falling within Mexico will be visible in the canvas. Let's do the same for the populated places layer. Now we are ready to create our visualization. We will use plugin named MMQGIS. And we just need to create so-called hub lines. Let's go to the MMQGIS. Hub lines distance. Well, this utility help us to connect hub layer earthquake with places with spoke layer populated places. And we just need to use name. Yes, we also can hub lines. And no, hub point layer, it is populated places. MMQGIS. We should firstly we should you add this MMQGIS plugin. If you have no this plugin installed in your system, MMQGIS, you should find this plugin and install it. Add it to your QGIS environment. Well, hub lines distance, populated places, name, work with places, allocation criteria nearest hub. Sorry, let me see. Matrix start. The processing may take a few minutes. You can see the progress on the bottom left corner of the QGIS window. And then the lines between populated places and earthquake places will appear. Let's try. Nearest hub, lines to hub, ready, run. Well, you can see 5,841 node created. And here you can see each epicenter of earthquake and the nearest city has created so-called hub lines. So this analysis can help us to understand probably damage of earthquake and the city that is situated not far from these epicenters.